Okay, 7-4 is about rational exponents. The word rational is another word for fraction, so we're really dealing with fractional exponents, but rational numbers are numbers that can be written as fractions. So we've got 125 to the 1/3. The power is in the numerator, the root is in the denominator. So this is really 125 to the first power. Oops, sorry, my finger's in the way. 125 to the first power, and we're taking the cube root of it, more commonly referred to as just the cube root of 125. We know the answer to that is 5. Not too terribly challenging. Using some of our other properties, 5 to the 1/2 times 5 to the 1/2, that's the same thing as saying 25 to the 1/2, because really what you've got is the square root of 5 and the square root of 5, which is just like what we've talked about before, the square root of 25. And once again, we know that those are both equal to the number 5. We have a last example here in example 1, the cube root of 10 times the cube root of 100. We know that's the cube root of 1,000. Now we can also multiply these two together and just write 1,000 to the 1/3 power. Either one of those gives me the result 10. Example 2 highlights another property, which I talked about a little bit before, that these rational exponents, the power is in the top and the root is in the bottom. So the fractional exponent has the power over the root. So if you're being asked to write x to the 3/5 in terms of its radical notation, the root on the outside is 5, and the power on the x on the inside is x to the 3rd. Now that could also be written as the 5th root of x to the 3rd power. Either one of those is acceptable. Well, when you see a decimal, the first thing I'd want to do is change it to a fraction. Okay, because that's going to help me understand what's going on here. Now, the negative in the exponent, which we'll take a look at in a little bit, causes the base to flip over. So, in other words, it pushes it to the denominator. So this is the same thing as 1 over y to the 5/2, which we know that that 2 in the denominator means a square root of y, and we're raising that to the 5th power. Another example that we could have is writing it back from the radical form to the exponential form. So the power divided by the root, since that's a square root, the index is 2. The power divided by the root, so that's b to the 2/5. In example 3, they have a story problem in the book. Let me just read through it. It's about space travel. It says bone loss for astronauts or lengthy space voyages may be prevented with a bed-like apparatus that rotates to simulate the effect of gravity. So they have this bed that spins, basically, in order to prevent bone loss, because it simulates gravity. In the formula, and I've listed the formula, it says that n is the rate of rotation, so this is your rate of rotation. A is the simulated acceleration, simulated because we're out in space and we don't really have gravity. And r is the radius. How fast would an apparatus with the radius of 1.7 have to rotate to simulate the acceleration of 9.8 meters per second that is due to Earth's gravity? So if we want 9.8, just like Earth's gravity, we have a radius of 1.7, how fast does this thing need to spin? Please keep in mind that this is a 0.5. If you'd like to use fractional exponents, um, be my guest, because sometimes it seems like you guys make mistakes when you have decimals for exponents. So if you'd rather see this formula 9.8 to the 1 half and 2 pi times 1.7 to the 1 half, that's fine. 9.8 to the 1 half is can't type. Approximately 3.13 over, and your denominator, 2 pi times 1.7 to the 0.5 is 8.19. Now when I divide those two things, 3.13 divided by 8.19, I end up with approximately 0.382. Okay? And that is in meters per second. I have a feeling that if you try to type this all in your calculator at one time, you'll make a mistake. So doing the numerator separate from the denominator, taking care of those at separate times, is going to help you get the correct answer. Next thing you need to be reminded of are properties which you probably already know about, such as when you multiply like bases, you add the exponents. When you take the power of a power, you multiply the exponents. The power of a product, you end up distributing this exponent on the outside to both the exponents on the inside. When you have a negative exponent, it causes the base to flip over. Instead of being a over 1, it's now 1 over a. Dividing like bases, we subtract our exponents, very similar to the whole multiplying where we add them, like we had in the first property. And this one's very similar to the distributing property up here, in that you distribute to both the numerator, all the exponents in the numerator, and all the exponents in the denominator. A couple of examples we can throw at you. Using these fractional exponents, if it's just a positive fraction, then what I usually do is I do the root first and the power second. Yes, you are allowed to separate 3/5 into 1/5 times 3. If you would multiply these back together, you would still get 3/5. But I know how to find the fifth root of negative 32. The fifth root of negative 32 is negative 2. And when we raise it to the third power, negative 2 times negative 2 times negative 2, I get negative 8. Making it smaller before I make it bigger will make this a lot easier. Just in case you happen to not have a calculator for some quiz in the future. Well, this is the same thing as 4 to the negative 7 over 2, right? Negative 3.5 is negative 7 over 2. Well, in this case, I have three things that I'm going to do. I know I'm going to do the root, then I'm going to do the power, but then I've got one last thing in this one that I didn't have in any of the other ones, and that's a negative 1 in the exponent. If you multiply 1/2 and 7 and negative 1 together, you get negative 7/2. So I always talk about the root, power, flip, because I know that the negative 1 is going to cause the base to flip over. So the root, power, flip. So square root 4 is 2. 2 to the 7th is 128. Flipping it over makes it 1 over 128. So there's my answer. Root, power, flip. Here's another one of those negative fractional exponents. We've got 25 to the 1/2, to the third, to the negative first. Root, power, flip. Root power flip. This one doesn't have the negative exponent, so it just is involving the root and the power. This one has all three: root, power, flip. Fourth root of 16 is 2. 2 cubed is 8. 8 to the negative first is 1 over 8. Root, power, flip. Now, in example 5, they're using those properties, right? We are going to distribute this exponent on the outside to all the exponents on the inside. So that's 16 to the negative 3/4 times y to the 6th, right? Because you take negative 8 times negative 3/4, and that gives you positive 6. So I will have to worry about this. This is already taken care of. So we've got root, power, and then the flip. You know what? I'm just not going to worry about this y to the 6th until I get done with this. So 4th root of 16 is 2. 2 to the 3rd is 8. 8 to the negative first is 1 over 8. So we have 1 over 8 times y to the 6th. Now, if you want to write that like this, or if you want to write it like this, I don't really care. Either one of those is fine. And they mean the exact same thing. Okay. We'll see you in class. I think that's all we have for the notes today.